Arrhenius equation is one of the most common topics in AQA A Level chemistry exam, either in paper 2 or in paper 3. This is a past paper question from 2024, and this question was in paper 3. It talks about the thermal decomposition of an alkene with an alcohol, so but 3-ene-1-ol, which is investigated at different temperature. The Arrhenius equation links the rate constant with the temperature and the activation energy. So the results from the investigation are used to calculate the rate constant at each temperature. And this table 2, give the results. So this is the temperature in Kelvin, this is 1 over T, and this is the rate constant, and this is the natural logarithm of the rate constant. Now they want you to complete table 2 with the missing values at 573 Kelvin. So 1 over T here is going to be 1.75 times 10 to the minus 3. And then the natural logarithm for the rate constant, this value will be minus 6.46. You can simply use your calculator to do these values. The second question is asking you about the overall order of the reaction. It can be deduced from a piece of information in one of the column headings in table 2. So what piece of information is this? This is the rate constant. So the piece of information is the K unit, which is second to the minus 1, which means the overall order is first order. Why is that? This is because the rate will be concentration over time in second, and if the K is the second minus to the minus 1, that means the rate is actually 1 unit of concentration times the rate constant, so it's first order. Then he wants you to plot the data from the table into the graph. Of course, they give you the equation, which is the normal logarithm, a natural logarithm for the equation, Arrhenius equation. And now I'm not going to do this in front of you. I've already done it. It's going to be a straight line. As we know, we plot the a natural logarithm of the rate constant on the y-axis and then 1 over t on the x-axis. Now you want you to use your graph from this question to calculate the value for the activation energy in kilojoule per mole for the thermal decomposition of that compound. And the gas constant, which is R, is 8.31. So when we look at the equation, we can see that the gradient for this one will equal minus, as you can see, minus EA over R. So minus activation energy over the R. You can just calculate the gradient from the graph. For me, what I've done is that I used 2 points because it's a straight line, 2 points from the table. So I used the first 2 points for the natural logarithm of K and for the 1 over T. And then I calculated the gradient. So the change in Y, which is the difference between the two values here, it's going to be 0.6, and this is over the change in the x, so it's going to be 0.03 times 10 to the minus 3. Of course, it's in the negative value, and that gave me a gradient of 20,000. So this is the gradient I calculated. Normally for these type of questions, because you bought the best fit line, which is a straight line, but at the same time, it doesn't go through all the points. So there's a range of accepted value. So the range here, the 20,000 lies within the accepted range. So the gradient for me equals minus 20,000. Now we can now calculate the EA, which gonna equal 20,000 times R, which is 8.31. That will give me 166 times 10 to the 3, but this is in joule per mole. Now I need to find the value in kilojoule per mole, so it's going to be simply 166. So this is the value again, the activation energy or the value. There will be a range accepted here, and this is within the accepted range. Now they want you to do the similar thermal decomposition of another compound, which is again an alkene, which has an alcohol functional group as well, which is going to decompose in the similar way. So they want you to deduce the structure of the alkene and the carbonyl compound. Let's have a look at the original structure and see how it decomposes. So now what we can see is that this is an alkene and it has four carbon atoms and has an alcohol. What happens here is that it was broken from here, from this carbon which is attached to the oxygen, and the other part left. So the competition took place between these two carbons, and then we replaced the OH with a carbon with a double bond or with a carbonyl group. So let's have a look at our new one now. So this one, let's draw this in a way that can help us to find the structure. So there is a CH2 here, and then we have this carbon here, which has two CH3s attached to it, and then it has an OH. And then it will be broken from here. So the thermal decomposition will take place here, and this part will give us the carbonyl group or the carbonyl compound, where a double bond will be generated here, and this one will give us the alkene. So the alkene will be CH2 and CH and then CH3. And then this is the carbonyl one. So this is the carbon. We're going to put the double bond O and then the two methyl group attached to it.